Welcome to this explainer on one of the most fascinating terraforming concepts on Earth, the Qattara Depression. I mean, it literally sounds like a concept pulled straight out of a science fiction novel, right? But transforming this massive, dry basin into a desert ocean is a very real, very serious proposal. So let's jump right in and break down the science, the economics, and the environmental realities behind this incredibly ambitious dream.
Just picture this for a second. Imagine the sheer, mind-boggling scale of digging a channel to link the Mediterranean Sea directly to a gigantic natural depression deep within Egypt's western desert. It is a bold thought experiment, a massive human intervention in the natural world. But, as we're going to see, altering the face of our planet is rarely as simple as just adding water.
Section 1. The Desert Ocean Dream, a Historic Vision.
So, the location we're focusing on is the Qattara Depression. Tucked away in the northwest of the Western Desert, it's actually one of the largest natural depressions in the entire world. For years, a historic vision has totally captivated planners and engineers, linked the Mediterranean Sea to this massive hole in the earth to create a sprawling artificial lake. The main goal? To harness the power of all that rushing water to generate massive amounts of electricity for the region. On paper, it looks like a brilliant, clean energy masterstroke. Just add water and power the desert.
Section 2. 4 Paths to Development. Evaluated Scenarios.
Well, modern science is essentially hitting the brakes on that original dream. Recent studies have carefully reevaluated the entire region, analyzing the long-term environmental, economic, and technical impacts. To try and balance regional development with natural resource conservation, researchers broke things down into 4 specific paths. They had to weigh storing water from massive energy generation against the necessity of desalinated farming. They also looked at lighter-touch approaches, like simply exploiting the natural elevation drop for power, or even developing the whole region without relying on a massive water reservoir at all.
Which brings us to Section 3, the Environmental Danger Zone, Severe Risks.
Here's the plot twist. The reality check from these recent evaluations introduces a massive complication. These water-based scenarios carry some incredibly complex environmental consequences. Threat number 1 is a hidden danger. Think about it. If you introduce millions of gallons of seawater into a desert depression, there's a very high probability of that saltwater leaking right into the groundwater aquifer. It can seep down into the earth, permanently corrupting the precious underground freshwater that the entire surrounding region literally relies on to survive.
But the threat absolutely does not stop underground. Introducing a massive saltwater body into the desert guarantees increased soil salinity. It's like a devastating chain reaction. The surrounding earth absorbs the salt, effectively poisoning neighboring agricultural lands and turning thriving farms into barren wastelands. So it starts with a lake and ends with the ruin of nearby farming community.
And beyond the soil and the water, we really have to consider the life that already exists there. The Qattara Depression is not an empty, lifeless hole. Flooding it threatens the rare species that have adapted to live there over millennia. Furthermore, introducing an artificial sea would completely disrupt the delicate ecological balance and biodiversity of the neighboring oases. You aren't just changing lines on a map. You are potentially wiping out highly specialized, fragile ecosystems. Let's shift our focus to Section 4, Hidden Wealth and High Costs, Economic Realities. In its natural, undisturbed state, the Qattara Depression is already a treasure trove of economic and geographical wealth. I mean, it features highly promising zones for oil and natural gas extraction, and it's rich in multiple mineral ores. As we just mentioned, it is home to rare desert ecosystems, and importantly, it contains geomorphological formations that are absolutely vital for scientists studying the historical evolution of the Western Desert. Flooding the depression would mean submerging and losing access to all of this existing, tangible wealth.
Then we have to look at the math. Studies clearly indicate a harsh economic reality here. The infrastructure cost required to execute this megaproject would be prohibitively high. When you contrast those astronomical, sky-high costs of digging canals and building massive infrastructure in the deep desert against the reality of today's technology, the math just doesn't add up. We currently have much better, cheaper, and way less destructive alternative energy options available to us. Why spend an absolute fortune to risk an entire ecosystem when solar or wind energy could achieve the exact same power goals for a fraction of the cost?
Finally, we arrive at Section 5, Balancing Progress and Preservation, Finding the Balance.
Ultimately, the Qatar Depression serves as a vital model for studying the relationship between sustainable development and environmental preservation. It proves the absolute necessity of rigorous, meticulous scientific planning before unleashing massive, irreversible changes on sensitive natural areas in the name of progress. We have to look at the full picture. We have to consider the hidden costs, the environmental domino effects, and the wealth we might be completely erasing.
Which leaves us with this final thought. When evaluating these massive terraforming megaprojects, is the dream of progress actually worth the environmental reality? It's so easy to just draw a blue line on a map from the sea to the desert, but the real world is incredibly complex. What do you think the limits of human intervention should be? Thanks for exploring this explainer on the Qatar paradox with me, and keep questioning the world around you.